Hello, today I'd like to show you a security monitoring tool stack that deploys itself and more importantly, what happens to your data once it's running. I'm going to kick off this deployment in the background. It's going to build a Kubernetes cluster from scratch, deploy Weza, ClickHouse, Kafka, all the supporting services. The demo environment for this project is intentionally kept simple, but just know that it is self-scaling. And as long as you have a hypervisor with the resources available, it will continue to lay out shards and horizontally grow as needed based on the demand put on the system. But for the demo environment, we're just going to be using two Talos nodes, which is the minimum. And then we have a Ubuntu CT that's just acting as our workstation. Regardless of the architecture that you start with, it will be able to self expand horizontally. It'll grow the shards. It'll add additional instances. There will be some backend integration that we'll need to do with the hypervisor, but that is also a scripted process. Once the service is running, it'll monitor that for us and spin up new machines as needed. So let's talk about the event lifecycle, how the data comes into this security platform or SIEM platform. These events can come in either through the Weza agents themselves, should you deploy any, syslog, which is any device that speaks syslog, so like firewalls, switches, routers, they can send their events directly to the manager over TCP or UDP. There's no agent required. We also have an agentless monitoring category for devices where you can't install an agent but have SSH or SNMP access. Weza can pull them remotely to check file integrity and system state, things like that. And lastly, we have API integration. So external tools and scripts can submit events via the Weza REST API, which is useful for custom log sources or just feeding data in from any other platform. Let's take a quick look at the architecture of this setup. What happens after investigation? So no matter which path an event takes to arrive, once it hits the Weza manager, the same processing chain kicks in. The manager is going to run the event through its decoder, which extracts structured fields from the raw log. Then it hits the rules engine, which Weza ships with thousands of rules out of the box, mapped to the MITRE ATT&CK framework. But you can also create custom ones. So it can flag things like brute force attempts, privilege escalation, file tampering, or known vulnerability patterns for row matches. It will generate an alert for you with a severity level. From there, the event is going two places simultaneously. It gets indexed into the OpenSearch engine, which is what powers the Weza dashboard for real-time searching. And if you have the full pipeline enabled, it's an option to not enable it just for demonstration purposes. But should you enable that for an actual like dev, QA, or prod environment, it's also going to get published to a Kafka topic called Weza events, which is going to feed into your long-term storage. And this is where you're really going to get some value out of this tool, because OpenSearch is great for real-time searching and dashboards, but it's not designed to hold years and years of event data cost effectively. That's where ClickHouse comes in. When Kafka is enabled, events flow from the Weza manager through FileBeat into a Kafka topic. ClickHouse has a native Kafka engine that consumes from that topic directly. A materialized view parses the JSON and extracts fields like the agent ID, rule ID, your source IP address, and the MITRE tactic. And then it's going to write them into a columnar table optimized for analytical queries. When Kafka is not enabled, though, a vector sidecar reads the Weza archive logs and streams them to ClickHouse directly. But either way, the data is going to end up in the same place. So speaking to tiered retention, ClickHouse stores your events across 3 tiers, and data moves between them automatically based on the age of that data. Those 3 tiers are going to be hot, warm, and cold. Natively, we want to make sure that in this deployment and the configuration that hot is going to target an SSD, so we maintain those fast queries on recent data. Warm going to HDD, something that's affordable but still queryable. And then cold is going to go through a platform called MiniIO. So it's archived and it's the cheapest long-term hold method available. The key thing that all three tiers are still queryable through the same ClickHouse SQL interface, whether an event is 1 hour old on the SSD or 2 years old in object storage. You run the same query, it just takes a little bit longer, the warm and cold tiers, than it does the hot tier. An important note to make is that the retention periods are identified in the configuration file. So all these retention windows are set there. For this demo, I have hot set to 1 day, warm set to 3 days, and a total retention at 7 days, so that I can watch the data cycle through the tiers somewhat quickly. So now let's dive into the actual architecture. I want to tie all these pieces together because each component in this stack has a specific job. Weza is the detection engine. It collects the events, decodes them, runs rules against it, generating alerts and things like that. It also gives you the dashboard for real-time monitoring, but Weza alone doesn't solve the long-term storage issue that plagues many enterprises. Kafka is going to sit between Weza and ClickHouse as a buffer. It absorbs ingestion spikes so that if you suddenly get a flood of events from, say, something like a network scan or a noisy host, ClickHouse doesn't get overwhelmed. Kata watches the Kafka consumer lag and automatically scales up the number of ClickHouse consumers if the backlog grows too high. And again, these are all thresholds definable in your configuration file. ClickHouse stores every event in a compressed columnar format that is incredibly fast to query. You can search millions of events by agent, by rule, IP, MITRE tactic, as I had mentioned before, and get your results in seconds. The important part is that you still own your data, right? It's sitting on your infrastructure, queryable whenever you need it. MiniEIO provides S3 compatible object storage for your cold tier, so your oldest events move to the cheapest storage automatically, and MetalLB gives all of these services real IP addresses on your networks, so agents and syslog sources can actually reach them. So you might be asking yourself, why is this actually necessary? And the answer is pretty straightforward, right? You want to collect security events from everywhere on your network. You want rules running against them so that you don't miss anything in real time, and you want to keep those events searchable for months or years without costing a fortune, where other tools are going to charge you based on like every event that you bring in, or every rule that you run, or how long it runs. There's so many different tactics that companies are taking to charge you based on the usage, that this is going to give you a very linear cost scale of, you're using this many resources, CPU, RAM, processing time to process your events and get them in, and then you are paying for the actual storage themselves, right? You're not paying a fee on top of what it costs to have the storage, like the disk space, available as well. And the reason you're getting charged like that is because this entire stack, the entire platform that we've put together here, is all built on open source. There are no per agent fees or per gig, like I was mentioning before, no like per gigabyte ingestion charges, no retention surcharges. You scale it on your own hardware and you keep the data as long as you need or want it. And that's kind of where we're going to end this video. I'll post another video kind of walking you through the environment, how you interact with Weza, what the UI looks like, logging in for the first time, what you need to do after the baseline deployment has been set up. But just wanted to give you an idea of what this was for and why you might be interested in it. So thanks for watching.